Hello everyone, welcome back to my channel Feynmath, and in this video we are going to complete the proof for gradient in spherical polar coordinates. So let me remind you, in the last three lectures we have been trying to derive an expression for a gradient in spherical polar coordinates, and so let me give you a short overview of what we have done in the past three lectures. And so what we have done is that we have expressed our Cartesian unit vectors in terms of polar unit vectors, which are shown on the screen. Which are shown on the screen. So Ex, Ey, Ez are expressed in terms of Er, E theta, E phi. That was our task 1, and our task 2 was to write our task 2 was to write the Cartesian Cartesian derivatives, that is del f by del x, del f by del y, and del f by del z in terms of polar derivatives. And we have remembered that we gave them a shorthand notation for small abc to my Cartesian derivatives and my capital letters for polar derivative, just to make the manipulations simpler. So that was our task 2. Now, so let me put again for small abc, del f by del x, del f by del y, and del f by del z. Now remember why we have done that. So if you haven't watched those previous three lectures, this will be hard to follow. So please, I would suggest you to go and watch those three lectures. I will actually link them in the description and also on the iTab, that you can see the link for the lectures. So let me remind you why we are doing this. So you see that we all know that my gradient in Cartesian coordinates was nothing but del f by del x Ex plus del f by del y Ey plus del f by del z Ez, right? So what we have done is that we have derived an expression for these guys in terms of polar coordinates, in terms of polar unit vectors, and we have also derived an expression for these guys in terms of polar derivatives, right? And what is the remaining task here? The remaining task is to just substitute them, because after substituting them, after doing some crazy manipulations, because again this is one of the video where your patience level would be tested, so please bear with me. And all we have to do is to just do substitution and to collect terms to actually get to the final answer. So we will do that today, and this will be the end of the end of this topic, which is gradient in spherical polar coordinates. So let me do that. Let's put that in. So let's plug in these expressions. So we have gradient, right, f x y z is equal to, we have our Ex vector. So our Ex vector is Er sine theta cos phi plus E theta cos theta cos phi plus minus sine phi E phi, and that will be multiplied by this guy, which is this one, right? So let me multiply this. 1 over r sine theta ar sine square theta cos phi plus b sine theta cos phi minus capital C sine phi. Then we have a plus term plus this guy, ey. So our ey is er sin theta sin phi plus cos theta sin phi e theta plus cos phi e phi. This whole guy multiplied with df by dy. So df by dy is this one multiplied by just give me a second. Just give me a moment, please. Yeah, 1 over r sin theta 1 over r sin theta ar sin square theta sin phi plus b cos theta sin phi minus c plus cos phi. Then we have a third term, which is this guy ez multiplied by this guy, right? So our ez is cos theta er minus sin theta e phi plus 0, sorry, this is e theta e phi multiplied by df by dz, which is 1 over r ar cos theta minus b sin theta plus 0c, capital C. So I have done nothing. I have just replaced my ex, ey, ez and df by dy, df by dx and df by dz by these expressions which are equation number 1 and equation number 2. Okay, I have just done nothing but just replacing them. Okay, sorry. Okay, so now what we need to do is we need to do some manipulations, right? So let's do that. First let me collect my er term. So this is now my gradient is a function of r theta phi, because we have just replaced everything with r theta phi, right? So I will have er and something plus e theta and something and plus e phi and something, right? All I need to do is to collect these terms. So let's do that. So first is er. Now er term will come when we have this guy multiplied with this entire term, this guy multiplied with this entire term, and lastly this term, this guy multiplied with this entire term, right? So let me write this down. So you have er is sin theta cos phi. So we have sin theta cos phi. Let me do this. Then I have multiplied by this term, which is 1 over r sin theta, which is r sin theta multiplied by this ar sin square theta cos phi plus b sin theta cos phi minus c sin phi, right? This is the first term, plus we will have another term, which is when this guy gets multiplied by this guy. So we have another term which is, let me write it down, sine theta sine phi upon 1 minus r sine theta, right? R sine phi, sine theta sine phi upon this guy. When this guy gets multiplied by this guy, we have 1 upon r sine theta, and this whole term which is ar sine square theta sine phi plus b cos theta sine phi plus c cos phi. And lastly, we have term which is this guy when this guy gets multiplied with this guy. So we have cos theta upon r ar cos theta minus b sine theta, right? This is my er term, just the er term, right? Plus we will have something e theta plus something e phi. Now I'm not going to evaluate every term in this section because it will get complicated. So first we will figure out the coefficient for er term. Then what we will do is that we will figure out the coefficient for e theta term, and I will leave as a homework to figure out the coefficient for e phi term, which is a simpler one. Okay, e theta. Okay, now let's just multiply things. So this sine theta cancels off, right? This cos phi get multiplied with this guy, so it will become cos square phi. So it will get multiplied with the entire term. So we have a. Okay, so let me do one thing. Let me just collect my a terms, right? Let me collect a term. So a term will be this r get cancels out. We have sine square theta cos square phi plus, and from here r this sine theta cancels out, r also cancels out, and we have sine square theta sine square phi, and lastly from this term we have cos square theta, right? Plus the b term. So b term you will have this guy gets multiplied with this guy, so we have sine theta cos square phi sine theta cos square phi. Then from here it will get cos theta sine square phi, and from the last term we will have minus sine theta cos theta, right? And then we lastly have the c term, which is capital C, and from c term we have, so this sine phi gets multiplied with cos phi, and there is a r over there is 1 over r there, so it will get c over r minus sine phi cos phi plus there is this cos phi and sine phi, so sine phi cos phi, and there is no c in the third expression, right? So we have just nothing, plus again we have those terms e theta something times e theta plus something times e phi, right? Okay, sorry, I'm suffering from cold. My voice may be a little distorted. Anyway, let's just collect terms er. So we have a. So from here I can take sine square theta common. So sine square theta common. Then I have cos square phi plus sine square phi plus cos square theta, right? plus b, if I take sine theta cos theta common from this side, sine theta cos theta, then I have cos square phi plus sine square phi minus sine theta cos theta, and lastly we have c over r. Oh, this just cancels away, right? Minus sine phi cos phi and sine phi cos phi. So this just cancels away and we are left with nothing. So we have plus e theta plus some e phi terms. Now here this is 1, this is 1, and we have again left with sine square theta plus cos square theta. So it will just give me er a times 1 plus b sine phi cos phi minus sine theta cos theta. So it will just give me nothing. So I have 0 plus 0, it will give me 0, and we have plus 0 times c. Then we have these additional terms e theta and e phi, right? So lastly we have er. I just have a times er plus something times e theta plus something times e phi. So we have completely solved, right? We have completely solved our er, the coefficient of er. Now the remaining task is to figure out the coefficient for e theta, right? E theta and e phi. So as I told you that I will leave as a homework to figure out the coefficient for e phi. So let's compute this e phi term, e theta term. And again we have to repeat the same process what we have did for er. So we have er plus there is e theta. Now for e theta, what we have to do? Here is the expression. We have to collect there we are. So what we have to do, what we have to do is to take this term and multiply with this entire term, and to take this term, multiply with this entire term, and take this term and multiply with this entire term, and then we have to collect coefficients, right? That's what we have to do. So let's do that. Again, it's a simple task. All it needs is patience. That's it. Okay. So when we multiply, so first term is cos theta sine phi with this entire term. So let me write that down. So we have cos theta cos phi divided by r sine theta ar sine square theta cos phi plus b sine theta cos phi minus capital C sine phi. Then we will have plus, then this term, this term multiplied with this entire term, because for the first time what we did is that we took this term and multiplied with this entire term. Second time we have to take this, multiply with this term. So let's do that. Cos theta sine phi. So we have cos theta sine phi divided by 1 over r sine theta. We have a r square sine theta sine phi. Let me check. Yes. B sine theta cos theta sine phi plus c cos phi. And then lastly we have this term multiplied with this entire term. So let's do that. It is minus sine theta. It is minus sine theta. Sorry, let me change my color. This plus become minus sine theta by r sine theta, right? Sorry, there is no r sine theta. There is just this term, which is this term, right? It is 1 over r a r cos theta. It is 1 over r, sorry, not this bracket, 1 over r a cos theta minus b sine theta plus 0c, right? Bracket close. And now just we have only one term, which is e phi, left to compute, right? Now again what we have to do is that we have to collect coefficients for a, then b, and then c, right? That's what we will do. So we have er, which is aer, sorry, e theta a. So this sine theta, so for a term this sine theta cancels one sine theta here, r cancels r, and we have cos theta cos square phi. This will multiply with this cos phi to give cos square phi, and we have just one sine theta, right? From the second term, r cancels r, sine theta cancels one sine theta, and we have cos theta sine theta sine square phi. And from the third term we have, there is a minus sine theta cos theta, right? Then let me collect the b term. b term will give me, so please check, b term will give you cos square theta cos square phi plus cos square theta sine square phi plus sine square theta. And the c term will give you, c by r will give you minus cos theta cos phi sine phi divided by sine theta plus sine phi cos theta cos phi divided by sine theta, and plus we have extra term, which is this one. So let me verify this. So c term from here gives me cos theta cos phi sine phi divided by r sine theta. So cos theta cos phi sine phi divided by r sine theta with a minus sign, and from here I get cos theta sine phi cos phi divided by r sine theta with a plus sign. Cos theta sine phi cos phi divided by r sine theta with a plus sign. Okay, this is fine. Now let's just manipulate these terms. So we have a er, right? Sorry, aer plus e theta, aer, then we have a. So again, if I take cos theta sine phi common, let me take cos theta sine phi common, then I have cos square phi plus sine square phi is common minus we have sine theta cos theta, right? Then we have a plus. Let me take cos square theta common. Here is a b. Then we have cos square phi plus sine square phi plus sine square theta. Then lastly we have c by r, and this just cancels away, right? This just cancels away, nothing left. So we have only plus something times e phi, right? Okay, so things are getting simplified. E theta, we have a, this is just 1, right? This is just 1, this is also 1. So we have a cos theta sine theta cos theta sine, sorry, this is sine theta or sine phi. Did I make a mistake? Yeah, this is theta cos theta and minus sine theta cos theta plus b, we have cos square theta plus sine square theta plus something's e phi, right? So this will give me just aer plus e theta. This term just cancels away, nothing left. So we have just, and this is just 1, so we have just b, right? Plus something times e phi. Did I make a mistake? There should be r. Let me check, please. Yeah, I did make a mistake, and the mistake is that when I multiplied this guy with the entire term, I forgot this r. Similarly here also, right? So there will be r over there. That's it. I forgot this r, right? So there will be r over there, b over r. That's it, nothing. B over r, and here I will have b by r. Please check this, right? I got my coefficients for the er and e theta, and as I told you that I will leave as an exercise the coefficient for e phi, right? But I will give you this coefficient. So this will come out to be, let me check, this will come out to be c by r sine theta. This is what this coefficient will turn out to be. So finally we have our expression for gradient in spherical polar coordinates. So after 3-4 lectures, after doing all the maths and doing all the manipulations, finally we are at the result, and the result is, it is a. So what is a? A is df by dr er plus b over r, which is nothing but 1 over r df by d theta e theta plus 1 over r sine theta df by d phi e phi, right? Let me box this, because this is the result that we have been trying to achieve for the past 4 lectures. Okay, and this is completely in polar coordinates, that is r, theta, phi, and we have er, e theta and e phi as the unit vectors. So we have achieved our task. So this is the final result that we have been trying to achieve for the past 4 lectures, and we have finally achieved it. So let me summarize this for you. What we have done is that we use the expression for Cartesian gradient, that is df by dx ex plus df by dy ey plus df by dz ez, and we have just plugged in the expressions that we have derived in lecture number 2 and lecture number 3, and to get the final expression for gradient in spherical polar coordinates. So already this video is getting long, so I will stop here. And so the plan for the next couple of videos is that I will do some examples related to gradient in spherical polar coordinates, and then we will move to divergence and curl in spherical polar coordinates, and probably also in cylindrical coordinates. And if you haven't seen my previous videos, please check them out, because without those videos you won't understand what we did in this lecture. And also please subscribe to my YouTube channel to show your support, and I hope to see you in my next video. So thank you for being with Feynmath.